everybody, the Miss Peg. I want to get you started on today with a maintaining mathematical proficiency warm-up exercise to get us ready for our chapter. I'm going to get right into it. On today, I want you to let you know that this is found in your blue geometry student workbook, and pretty sure is, page 1. Alright, so you just turn into page 1. You can do the work in the book, follow along in the book, go ahead, snap a photo, and upload it, or you can go ahead and maybe type your entries or your answers into the space provided. But a photo will do just fine. You can keep everything kind of together in your book as we go along. That way when you're studying or looking back for help, all your pages are there for you in a row. And you can remember the work that we've been doing. Alright? So if you notice here let me grab my pen, and hopefully I'll do a good job with the pen today. It's a little finicky, and we're new to a school year, so be patient with me on this pen. So I am writing on a graphic tablet so that we can, there we go, writing on with a graphic tablet so that you can see the work on the page. And hopefully, let's see what we got here. Alright, so it's coming through. Alright, so number 1, let's jump right into it. The first thing I notice is I have these lines on the side of my math problem, and those lines there mean absolute value. Absolute value is how far away from 0 you are. So for an example, if you are 200 feet backwards, you're still 200 feet away from 0. And if you're 200 feet forwards, you're still 200 feet away from 0. So actually, absolute value is never a negative number in the end, although it may be represented here like we see a -3 plus a -1. So if I do -3 plus -1, remember negative, negative, they're going to keep going in the negative direction, so I have -4. My absolute value bars that stand up and down like this are still there. So how far away from 0 is -4? Well, it's 4 points away, whether it's positive or negative direction. So it just means 4 points away. So absolute value would be 4. This is kind of the long-winded way to explain it, but the point is absolute value is never going to be a negative number in the end, but you have to make sure you're doing your computation correctly in the meantime. So on to number 2, we have 10 minus 11, so that's going to give me -1. Again, the absolute value of -1 is going to be the number 1. That's so weird. The number 1, let me get my pen back here. Sorry for the mess. We'll get it together, or at least I'll get it together over the next week or so, back practicing with this writing. It's a little tricky on the screen. Find my spot here. And we're at 1. That is not working. I think it's because I have 2 screens up. So either way, let me come over here, clear that for us, and move on. I want you to finish this page, but if you see here, I'm gonna scroll down to number 4. Okay, number 4 is a little bit tricky if you are needing a review of subtracting negative numbers. So if you have a number 9, so here's my 9, minus -1. Well, wherever you see subtraction and negatives together, I'm not sure if you remember, there's a rule that means you're going to add the opposite. So actually this subtraction would turn to a plus, so it would be 9 plus, and then you'll take the opposite of the second term. So if it's -1, that's going to be +1. So we have 9 plus 1 is 10, and we're looking for the absolute value of 10, which is 10. So weird that it's being duplicated on this side of the screen. Don't worry about that. So that's an example there for how you do when you have subtraction of negative numbers. Alright, so I want to keep that clear. That's something you'll need to know on this page. And then on the bottom on this page, you're going to have, we're here with area of a triangle. Alright, we are in geometry. We'll be dealing a lot with shapes and a lot with formulas. That is so funny. It's like complete doubled. So what I'm writing here is the area of a triangle. Area equals 1/2 the base times the height. So what you do is just figure out what's the base and what's the height. So here, my base is 16 centimeters, so I'm going to put 16 in for the base. I'm going to put a dot. That means multiply here, because when you have letters like this stuck together, the base times the height, that means we're multiplying. So I have 16, and then the height in this problem is given here clearly as 15 centimeters. So I'll put 15 centimeters in there. And that's where I'll have to do some math work. I want to say that's going to be 240, but I need to check myself. 240, math teacher does know multiplication. All right, so 16 times 15, I'm going to write it over here, is 240. So that's where that came in. But what was out in front of that was still a 1/2. Okay, so 1/2 of 240. The way I like to think of that, instead of doing this whole math problem out and doing making 240 into a fraction and multiplying across the top and across the bottom, I just think about it if I was talking to one of my friends. So if I have $240 and I get half of it, well, how much do you get? And that's going to be $120. So in this case, we're talking about centimeters. We're talking about the measurement, or the area measurement, of this triangle would be 120. And we always have to have an extension when we're measuring things. So here our units were centimeters. And remember, when we're doing area, it's always going to be squared. So that's a brief review. You're going to use area equals 1/2 base times height for numbers 11 and for number 12. Let me clear the screen over here. You're going to finish that page and take a screenshot, or a picture, upload it for credit. I think that's it for today. Anything you have not done yet, please go back and get that done. It's very important, and we'll see you in class on tomorrow. Have a great day.